The next reaction that we are going to study is the reaction between a base and an acid. When a base reacts with an acid, a salt is produced and a water molecule is produced, and the acid is neutralized. So base plus acid produces salt plus water. And before moving on, I would first give you a brief reintroduction of what a base is. Bases were proton acceptors. Protons are H plus 1 ions. So any compound that accepts or gains H plus 1 ion, that compound would be called a base. Well, or vice versa, an acid is exactly the opposite. It's a proton donor or H plus 1 donor. So any compound that gives off H plus 1 ion, that would be an acid. So the category of compounds that can be called as bases are metal oxides, metal hydroxides. So any metal bonded with oxygen or any metal bonded with hydroxide, that's most likely a base. Then you have ammonium hydroxide as well and ammonia as well. So these are all your different category of compounds, common category of compounds that are classified as bases. And then you have acids. We already did all the formulas of acids. Hydrochloric acid was HCl. H2SO4 was sulfuric acid, HNO3 was nitric acid, etc. You had phosphoric and carbonic acid. So any compound that has H plus 1 ion, it can possibly act as an acid because it can give off H plus 1 ion. So when a base reacts with an acid, it produces salt plus water. So I'm now going to pick a metal oxide. I'm going to do this reaction first, a metal oxide with an acid, and it's going to produce salt plus water. So let's pick one metal oxide, and I'm going to pick sodium oxide. Now sodium oxide is going to have the formula. Sodium is +1, it's in group 1. Oxygen is 2-, so the formula is going to be Na2O. So sodium oxide is a base. It's a metal oxide. I'm going to react it with an acid, and let's pick sulfuric acid. So when sodium oxide reacts with sulfuric acid, and remember this one is an acid, a salt would be produced and a water molecule would be produced. So I'm going to write down H2O as it is, and I'm going to try and figure out what the formula of the salt is. Now remember, salt is produced when an acid is neutralized. So what that means is that if I want to neutralize an acid, I need to get rid of these hydrogen ions. So if I replace the hydrogen ions in an acid with the other positive ion, which is the sodium ion, if I replace the hydrogen ions in the acid with some other positive ion, which in this case are going to be sodium ions, that would result in the formation of a salt. So the formula of that salt is going to be get rid of the H in the acid and put sodium ions in its place, and it's going to be NaSO4. SO4 is 2-, sulfate is 2-. So using the crisscross method, the formula of the salt is going to be Na2SO4. And I'm going to rub off the charges because the overall charge of on this compound, sodium sulfate, is going to be 0. The positive and negative charges cancel each other out. So the final salt is sodium sulfate plus water. So this is the reaction, and all the elements in this reaction are balanced. There's the 2 sodium ions. There's 2 sodium ions on the right hand side as well. There are 2 hydrogen ions on the left hand side. There are 2 hydrogens on the right hand side. There are 4 + 1, 5 oxygens on the left hand side. So there are 4 + 1, 5 oxygens. So everything is balanced. So this is a balanced equation. So a base, sodium oxide, is reacting with sulfuric acid, which is H2SO4, and it's producing a salt and a water molecule. I am now going to do another reaction in which magnesium oxide, another metal oxide, another base, is reacting with an acid, nitric acid in this case. So firstly, I'm going to figure out what the formula of magnesium oxide is. Remember, magnesium is in group 2, so it's 2+. Oxygen is group 6, so it's 2-. So since Mg is 2+, O is 2-, so the formula is going to be MgO. Plus, they're reacting with nitric acid. Nitric acid is HNO3. So it's a base plus acid reaction, and the product is going to be a salt and a water molecule. So let's write down water first, and let's try and figure out what the salt is. Remember, again, a salt is produced when an acid is neutralized. You need to get rid of the H plus 1 ions in the acid and substitute those H plus 1 ions with any other positive ion, which in this case is the magnesium ion. This is the other positive ion. So instead of this H plus 1, substitute it with Mg2+. So when we do that, when we substitute Mg instead of H, the formula is going to be Mg and NO3. Now Mg is 2+, NO3 is 1-, and using the crisscross method, this should be there should be 2 NO3, so it's magnesium nitrate. That's the formula of magnesium nitrate. And remove the charges, the overall charge is going to be 0. So this is the equation, and the last thing that we need to do is we need to balance this equation. So if we balance this equation, you would see that there are 2 nitrate ions. There's only 1 nitrate ion over here, so we need to balance that. And the rest of the equation looks balanced. There are 2 hydrogens over here, the 2 hydrogens over here, there's 1 oxygen, and there's 6 oxygens over here, so that's a total of 7 oxygens. There are 6 oxygens over here because there are two HNO3 molecules, and there's 1 over here, that's 7 oxygens. Mg is balanced as well, so the entire equation is balanced. So this is the reaction magnesium oxide with nitric acid producing magnesium nitrate plus water. Let's do this third reaction now. You have aluminium oxide, which is another metal oxide, so it's a base reacting with sulfuric acid. Now we first need to figure out what the formula of aluminium oxide is. Now aluminium is in group 3, so it has a charge of 3 plus. Oxygen is in group 6, so it has a charge of 2 minus. Using the crisscross method, the formula of aluminium oxide is going to be there's going to be 2 aluminiums and 3 oxide ions, and get rid of the charges. The overall charge is going to be 0. So aluminium oxide is reacting with sulfuric acid, which is H2SO4. So it's a base plus acid reaction, and they would end up producing a water molecule, which is H2O, plus a salt. Now the salt again is when an acid is neutralized, get rid of the H in the acid and replace it with the other positive ion, which is aluminium ion in this case. So put aluminium ion instead of the H ion in the acid, so that's how the acid would be neutralized. So it's going to be aluminium sulfate. SO4 is 2 minus, aluminium is 3 plus. So using the crisscross method, there would be 2 aluminiums and there are going to be 3 sulfate ions in the formula. And I'm now going to remove the charges. The overall charge is going to be 0. The next step is to balance the equation. So we're going to try and balance this equation now. Now remember, when you're balancing equations, balance the element that is easiest to balance, that comes in the least number of places. So aluminium, it's only occurring in 2 places and it's already balanced. Next is sulfur. Sulfur is over here and it's over here, so it's only in 2 places. So there are 3 sulfurs over here, there's only 1 over here, so there should be 3 molecules of H2SO4. That would give us 3 sulfurs. Then the element that is coming only in 2 places is hydrogen. It's over here and over here. There are 6 hydrogens over here, so there should be 6 hydrogens over here as well. So that would be 3 H2O. Now the hardest element to balance, which in this case was oxygen, because it was coming in a lot of places. Oxygen was over here in this 2nd place, 3rd and 4th. It was occurring in 4 places. If you balance all the easier elements, the most difficult ones should automatically be balanced. So there are 3 oxygens over here. There are 4 in 1 molecule of H2SO4. In 3 molecules there would be 12, so 12 plus 3, 15. Here you have 3 sulfate ions, so that's 12, and there are 3 water molecules, so that's 3. So oxygen there are 15 oxygens over here and 15 oxygens in the reactants as well. So oxygen is automatically balanced.